In this video, we're going to talk about graphing exponential functions by transformations. So we're going to graph a variety of exponential functions by transformations. We'll make sure the original graph has at least 3 points, and we're going to write the domain and range of the final transformed function in interval notation. So again, this function's parent function is f of x is equal to 2 to the x. Okay? So I've already come up with 3 ordered pairs. Again, I will use -1, 0, and 1 throughout. Okay? Now, let's list out the order of transformations. So first, I need to do 2 to the x plus 1, and that'll move the graph to the left 1. Let's take care of the negative inside the function. That will reflect across the y or f of x axes. And now let's deal with the -3, which will move it down 3. All right, so let's graph the original. All right, so now I want to move everything to the left 1. Notice the domain and the range has not changed. Now, I want to reflect across the y or f of x axes from the blue. So again, the domain and the range has not changed. So now let's move everything down 3. Okay. Now, it looks like the range has changed here. So now let's take a look at that final black transform function. Well, the domain is -infinity to +infinity. Now, what is the range? It's no longer 0 to infinity. It looks like it's moved down 3. So that should be -3 to infinity. So that is the range of the final transform function. Okay, so now let's take a look at another example here. So again, the parent function is still h of x is equal to 2 to the x. So I use the same 3 ordered pairs that I used for the previous example. So now I want to be able to do this by transformations. So first off, let's take care of the -3. So now that's going to move the graph to the right 3. Now we need to take care of the negative. Now, because the negative is outside the function, this is going to reflect across the x-axis. And then the +3, we're going to go up 3. So again, now I want to be able to do the graph the original function. Now I want to go to the right 3. Now I want to reflect across the x-axis. Now notice here the range is changing. It is no longer 0 to infinity. It looks like it's -infinity to 0. And now I want to move up 3. Now, So what is the domain? Well, the domain for this has not changed. That is still going to be negative infinity to positive infinity. Now, what is the range for this? Well, because it's pointing down, we know it goes from negative infinity, and now it goes up to positive 3. So now let's take a look at the picture on Desmos. Okay? So you can tell this and the final black picture are very, very similar. Okay, one other example I want to take a look at then is the base e exponential function. And all that is f of x is equal to e to the x, where e is the natural base and e is about that particular decimal. It's an irrational number similarly to pi. Okay? So now I want to graph this by transformations and then write the domain and range of the final transform function in interval notation. Okay? So e to the negative first power, if you put that into your calculator, that should be approximately 4/10. Okay? You know what e to the 0 is, that's 1. And then e to the first is approximately 2 7/10. Now, let's do the other transformations. Okay? So, we need to take care of the negative first. Again, because this is outside the function, I am reflecting across the x-axis. And the only other transformation is the plus 2, meaning that we're going to go up 2. Okay, so now let's take a look at this particular graph. So again, I'll change this f of x and label. So we've got negative 1 and about 4/10. We got 0, 1. And we got 1 and 2 7/10. Very, very similar to 2 to the x. It just goes up a little bit more quickly. So now I want to reflect this across the x-axis. And now I want to go up 2 for this. Okay, so now let's take a look at the domain and the range for this. Again, the domain is still going to be all real numbers. That has not changed throughout all of these problems. Now the range, again, because the arrow is pointing down, we know that's negative infinity. And it looks like the boundary is going to be at 2. And because it's plus 2 in this problem, that would seem to make sense here. Okay? So now let's take a look at this on Desmos. Okay? And again, the green here looks very, very similar to my red here.